All right, so what we're going to show here today is the exam portion of the functional hallux rehabilitation. What we check is a standard orthopedic test called functional hallux limitus, or FHL. What that mimics is what's called the windlass mechanism of Hicks, which is the proper biomechanics of running or walking. Every step that you take, there's a series of events that has to happen. A has to lead to B, C, D, E, F, G, on up the leg. And that needs to happen every step. So if that kinetic chain, if that series of events is off times every step, then basically you're setting yourself up to have different issues, whether it's foot and ankle issues, shin issues, knee issues, hip issues. You're susceptible to any number of those different issues when what should be happening every step isn't happening. So again, the test that we do is called functional hallux limitus to see what's happening. So every step biomechanically starts with somewhat of a heel strike, usually. Then the foot bends backwards, then the toes bend backwards, and then toe off. So you have that motion every step. So there is somewhat of a heel strike, then the foot bends back, then the toes bend back, then motion goes up the leg. So we want to make sure that that all happens biomechanically every step. The way we test what this functional hallux limitus test is you should have full range of motion of the toes from up here. Because every step the foot bends back, then the toes need to bend all the way back after that. So your toes bend that far back. Are you able to see that on the camera? So your toes bend that far back, so it should be able to freely do that from up here. So that's what we're going to check. So as you're walking or running, keep this nice and relaxed like you are. Heel strike, foot bends back, the toes bend back, and then hopefully you can see her whole leg move then after I bend her big toe back. So to break it down then, heel strike, foot bends back, toes bend back. When the toes bend back, that pushes motion through the joints in the foot, which then causes the arch to raise up. When the arch raises up, that causes the shin to roll out. After the shin rolls out, that causes the knee to slightly bend and roll out, which then after the knee rolls out, that then causes the hip to roll out. So biomechanically, that's what should be happening every step. Let's go ahead and stop.